Cool. So that's for number 3. Now, for the last one on this section. Whew, man, almost there. This one's a little more complicated. It's okay. We got this, though. We got this. I hope. Okay. Cool. So, now, we want to figure out when the radius is smaller than A. So when it's inside, so here's A. So we want a radius, let's say the point inside here. So our radius is kind of tiny here. Let's see, radius R. So it's inside. So this is the kind of the tough one. This is the one I definitely missed because, yeah, I didn't think about it. Okay, so remember that the overall charge of the sphere is 2q, right? So the overall charge of the sphere is 2q. But the charge enclosed in our new Gaussian surface, new sphere that we drew, this dotted line here that I drew, it's only a portion of the overall charge. But we don't know what it is. So let's say it's x. Well, how do we figure out what the charge enclosed is, right? Or instead of x, let's say charge, let's call it q enclosed, right? How do we figure out what the charge is on the inside? Well, the way that I like to do this, and there might be other ways to do it, is we can set up a ratio. We know that the volume, what's the volume of our sphere with A radius? The volume of that sphere, so the volume of the actual volume of the sphere that's charged 2q. So what's the volume of that? Well, a volume of remember it has a radius of A. So the volume of that is 4 pi, our radius is A. So remember, volume of a cube sphere is 4 pi r cubed divided by 3. So our r in this case is A, right? Our radius is A. So A cubed divided by 3. And it's proportional to the volume of the Gaussian surface that we made. This dotted, so now if here's A, then the Gaussian surface I made is that right there. So we need to find the volume of that sphere with radius r. And so the volume of this little sphere inside here is 4 pi r cubed divided by 3. So now, the reason that we're doing that is because we want to figure out what the charged enclosed is. To figure out the charged enclosed, we just need to multiply this bottom here over here, right? So charged enclosed is equal to 2q, and we multiply it by 4 pi over 3 r cubed divided by all this right here, 4 pi 3 a to the third. Well, now notice 4 pi's are going to cancel, and we are left with the charged enclosed. So charged enclosed is equal to, should be a cubed down here, is equal to, if we get rid of these, so charged enclosed is 2q r to the third a to the third divided by a to the third. Okay. So remember that. That's really important. Oh, guys, can you guys see that? Oh my gosh, I need to erase this. Let's see. Okay. Let's see. Cool. Hopefully everyone gets that part. So it's 2q r to the third a. Cool. Okay, so that's charged and closed. Gosh. Charged and closed. Okay, cool. So now, going back to, that's not it yet. Now, remember, we said that our electric field times the surface area of our sphere that we made, which is 4 pi r squared, is equal to the charged enclosed, which the charged enclosed here we found was 2q r to the third divided by a cubed divided by epsilon naught. Don't forget epsilon naught, that's important. So now, to figure out what E is, the electric field, we just got to divide over. So we get that the electric field is equal to 2q r. Well, if we divide by r squared here, we're going to be left with 1r on the top. So 1r divided by, so we'd have 4 pi, got rid of that r squared, and we just have epsilon naught a cubed. So this is the electric field at any point inside that insulating sphere. Whew! All right, cool. Hopefully that helped.